Hi, sixth graders. This is Mrs. Gall. Today we're going to talk to writing equations. Go ahead and get your math notebook open to a fresh page and put the title Writing Equations at the top of your notebook. When you're ready, click play. So we're going to start and we're going to break this down piece by piece to help us set up what this would look like as an equation. Our goal is to write the equation and then solve it. So we have Marisol and Ivy who spent a total of $22 at lunch. That's an important piece. Our total is $22. Ivy's lunch costs $5 more than Marisol's. If I wanted to represent what Ivy's lunch and Marisol's lunches would be as expressions, let's do that now because setting those up as expressions is going to help us set this up as an equation. Ivy's lunch was $5 more than Marisol's. $5 more than. Do we know how much Marisol's lunch was? No, so we're going to use an unknown, pick a variable, maybe it's M. So to represent Ivy's lunch, we're going to need 5 more than M. So M plus 5. That would be Ivy's lunch. To represent Marisol's lunch, we would just use our variable M because we know that Ivy's was 5 more than M, but we don't know what Marisol's lunch was. So there's Marisol's lunch represented with a variable and Ivy's lunch represented as M plus 5. Now what we need to do is combine our pieces together to create an equation. On one side of our equation should be our total. Let's go back up. We received our total quite early on in the problem. Marisol and Ivy spent a total of $22 at lunch. Your total should always be by itself on one side of the equal sign. That's what your expression should equal when you add all the pieces together if you knew what M was. On the other side of the equal sign is our expressions that would total to equal that 22. I know I have Marisol's lunch, which is M, and then I have Ivy's lunch, which is M plus 5. I look for any like terms, which would be my M's. M plus M is 2M. My constant of 5, I do not have any other like terms, so that stays by itself. And we set that equal to our total, which is 22. So our equation that works for this problem is 2m plus 5 equals 22. I'm going to clear my writing because that's a little bit nicely done, or a little bit nicer done here with the yellow. Then if I wanted you to solve it, then you would go through the solving process. One thing I want you to be aware of is some people, when they're writing out their equation, they accidentally write out the steps for solving and say that that's the equation. So they might write down 22 minus 5 and then divide it by 2 to equal M. But remember, that's not setting up the equation, that's actually solving the equation. So once we have our equation set up like this, then we can go through the solving process. Oops. To solve, we would subtract 5 from both sides. Start by getting rid of that constant. We're left with 2m on the left equals 17 on the right. We then would divide both sides by 2 to get m by itself. M equals 17 divided by 2, which is 8.5. That means Marisol's lunch, because M equals 8.5, Marisol's lunch is $8.50, because that's M. Ivy's lunch is 5 more than that, so Ivy's lunch is $13.50 if we added 5 to our $8.50. All right, let's try another one. Surfboards are rented for $16 per hour. Jade has $96. How many hours can she rent a surfboard? Okay, let's think about the pieces we have and know. We know that it's $16 per hour, and we know Jade has $96. Per hour means per 1 hour. So let's think about setting this up as an equation. Remember, equations all have equal signs. What's our total that Jade has? Well, our total is that amount she has, $96. That means that piece is going to be by itself on one side of the equal sign. What's the piece that we're going to use to get up to that $96? Well, we need to use our 16. We know that's the cost that a surfboard is per hour. What's our unknown? If we go back into our problem, we kind of have to look at the question to figure out our unknown. It's how many hours can she rent? We know that it's $16 per hour, but we don't know how many hours she's going to be able to afford with her $96. So we're going to take our 16, and what operation do you think we would do with the hours? We would multiply 16 times h to figure out how many hours she can pay for with her $96. That's what our equation would look like if we set it up. To then solve my equation, we would take the inverse of 16 times h, which is 2 divided by 16. And thinking about 96 divided by 16, that would get us 6 hours is how much she can pay for with her $96. So here's what our equation looks like set up, and here's our answer. Katie wants to buy a new phone. The phone she wants costs $210. If she earns $30 per week babysitting and has already saved $60, how many weeks will she need to save for? Let's go in and look for some important pieces in this equation. We know that the phone costs $210. That's the total cost of the phone. That piece is going to go all by itself on one side of the equation, the total that our expression should set up to equal. Let's look at the other pieces that they gave. $30 per week. $30 per week, and she has already saved $60. The unknown is how many weeks she will need to save for. So think about this, which piece, the 30 or the 60, is kind of the flat rate that isn't going to change. It's already happened. It's going to stay constant by itself. That piece is our $60 because it's the money that's already saved. It's not going to change. She's going to add to it, but that's a constant piece. We're not going to multiply that by anything. It's just going to get added into our total. So I'm going to include that in my equation. The other part of our equation that we have, or our expression that we would set up on this side, is the $30 per week. I know we're trying to figure out how many weeks, and what I do know is she makes $30 per week. If I were to take $30 and multiply it by the number of weeks that we would need, and then add that to our $60 that were already saved, that's going to be able to add up and equal our $210 that she needs. Our unknown, remember, is how many weeks that's going to take. So we could set that up as 30 times the number of weeks plus 60 should equal our $210. That is our equation set up. Now we could solve. Notice that in the equation I wrote out, we had 210 on the left-hand side and then 30W plus 60 on the right-hand side. But when I set it up, I reversed that. Either way is okay. We're looking for, do you have the right pieces together? Not necessarily which side they're on. So 210 is by itself and 210 is by itself. On the other side, we have 30 times W and we're adding that to a 60. It's okay if you did 60 plus 30 times W, as long as you have both pieces as positives and they're being added together. Now we could go through and solve. Start by moving your constant by subtracting 60 on both sides. That gives us 150 equals 30W. To get W by itself, we're going to, oops, I didn't cancel out. We're going to divide by 30 to get W by itself. Our zeros cancel out, and 15 divided by 3 is 5. That means it's going to take her 5 weeks to get up to $210 with the $60 she's already saved and the $30 that she'll make each week. Zach has 6 shirts. This is 4 less than twice the number of shirts, we can use N for shirts, that Xavier has. Zach has 6 shirts. This is 4 less than twice the number of shirts, N, that Xavier has. Let's set this up thinking about each of our people and what expressions we would use to represent them. We know, first of all, that Zach has 6 shirts. We then know that this is 4 less than twice the number of shirts, they want us to use N, that Xavier has. So let's go ahead, 6 is our total number of shirts that Zach has. Let's set that up on one side of our equation. Can you come up with an expression on the other side that matches this second sentence, 4 less than twice the number of shirts that Xavier has? Go ahead and pause if you'd like to try that now. Press play when you're ready to hear the answer. First thing I see, you guys, is 4 less than. If I think about 4 less than, that means I'm going to be taking 4 away from something to get 4 less than that. What am I taking 4 away from? Well, that's the next part of my expression. Twice the number of shirts, which we're using N. How do I find twice of N? Twice means to multiply by 2. 2 times N minus 4 is going to equal the 6 shirts that Zach has. I then could solve to figure out what Xavier has. To solve, I would add 4 to both sides. I'd be left with 2N equals 10. I divide both sides by 2. I figure out that the number of shirts for Xavier is 5. Notice when they set it up on the screen, they flipped and 6 was by itself on the left and then 2N minus 4 was on the right. Either way is okay. 6 is by itself and 2N minus 4 is by itself on the other side. Notice that minus 4 needs to come last in that expression of 2N minus 4 because 4 less than something means you're taking that away at the end of it. Oops. There we go. Try this one on your own. Jeremy has 13 baseball cards, which is 7 more than 3 times the number Michael has. Pause the video, think about your total on one side and the expression that will equal that total on the other side. Then try solving. Press play when you're ready to see the answer. Jeremy has 13 baseball cards, so that's going to be by itself on one side. This is 7 more than, so we're adding 7 to 3 times the number Michael has, 3 times Michael's. From here we can solve. I would subtract 7 from both sides to get our constants together. 13 minus 7 is 6. My 7's cancel out on the right. I'm left with 3m. Divide both sides by 3, and we get 6 divided by 3, which is 2. So the 2 pieces I'm looking for there, can you set up your equation as 13 equals 7 plus 3m? And then can you figure out that m equals 2? All right, guys, that's all for today. Check in with your teacher if you have any questions about writing equations.